Hello friends, welcome back to CloudPedagogy. In today's FAQ session, we are going to know more about identity and access management. So let's start with our questionnaires. What is AWS Identity and Access Management, which is IAM? IAM provides fine-grained access control across all of AWS. With IAM, you can control access to services and resources under specific conditions. Use IAM policies to manage permissions for your workforce and systems to ensure least privilege. IAM is offered at no additional charge. Next question, how does IAM work and what can I do with it? IAM provides authentication and authorization for AWS services. A service evaluates if an AWS request is allowed or denied. Access is denied by default and is allowed only when a policy explicitly grants access. You can attach policies to roles and resources to control access across AWS. Next, what are least privilege permissions? When you set permissions with IAM policies, grant only the permissions required to perform a task. This practice is known as granting least privilege. You can apply least privilege permissions in IAM by defining the actions that can be taken on specific resources under specific conditions. Next question, how do I get started with IAM? To get started using IAM to manage permissions for AWS services and resources, create an IAM role and grant it permissions. For workforce users, create a role that can be assumed by your identity provider. For example, for systems, create a role that can be assumed by the service you are using, such as an Amazon EC2 or AWS Lambda. After you create a role, you can attach a policy to the role to grant permissions that meet your needs. When you are just starting out, you might not know the specific permissions you need, so you can start with broader permissions. AWS managed policies provide permissions to help you get started and are available in all AWS accounts. Then reduce permissions further by defining customer managed policies specific to your use cases. You can create and manage policies and roles in the IAM console or via AWS APIs or even AWS CLI. Next, see how the IAM resources are in AWS. So what are IAM roles and how do they work? AWS Identity and Access Management roles provide a way to access AWS by relying on temporary security credentials. Each role has a set of permissions for making AWS service requests, and a role is not associated with a specific user or group. Instead, trusted entities such as identity providers or AWS services assume roles. So why should I use IAM roles? You should use IAM roles to grant access to your AWS accounts by relying on short-term credentials because it's a security best practice. Authorized identities, which can be AWS services or users from your identity provider, can assume roles to make AWS requests. To grant permissions to a role, attach an IAM policy to it. Next question, what are IAM users and should I still be using them? IAM users are identities with long-term credentials. You might be using IAM users for workforce users. In this case, AWS recommends using an identity provider and federating into AWS by assuming roles. You can also use roles to grant cross-account access to services and features such as AWS Lambda functions. In some scenarios, you might require IAM users with access keys that have long-term credentials with access to your AWS account. For these scenarios, AWS recommends using IAM access lost used information to rotate credentials often and remove credentials that are not being used. So what are IAM policies exactly? IAM policies define permissions for the entities you attach them to. For example, to grant access to an IAM role, attach a policy to that role. The permissions defined in the policy determine whether requests are allowed or denied. You can also attach policies to some resources such as Amazon S3 bucket to grant direct cross-account access as well. And you can attach policies to an AWS organization or organizational unit to restrict access across multiple accounts. AWS evaluates these policies when an IAM role makes a request. Next, we'll see how to grant access in IAM. So, how do I grant access to services and resources by using IAM? To grant access to services and resources by using AWS IAM, attach IAM policies to roles or resources. You can start by attaching AWS managed policies which are owned or updated by AWS and are available in all AWS accounts. If you know the specific permissions required for your use cases, you can create customer managed policies and attach them to the roles. Some AWS resources provide a way to grant access by defining a policy attached to resources such as Amazon S3 buckets. These resource-based policies allows you to grant direct or cross-account access to the resources they are attached to. Next, how do I create IAM policies? To assign permissions to a role or resource, first you create a policy, which is in JSON format, which is elaborated as JavaScript object notation document that defines the permissions. This document includes permission statements that grant or deny access to specific service actions, resources, and other conditions. After you create a policy, you can attach it to one or more AWS roles to grant permissions to your AWS account. To grant direct cross-account access to resources such as an AWS S3 bucket, use resource-based policies. Create your policies in the IAM console or via AWS APIs or even AWS CLI. Next, what are AWS managed policies and when should I use them? AWS managed policies are created and administered by AWS and cover common use cases. Getting started, you can grant broader permissions by using the AWS managed policies that are available in your AWS account and common across all AWS accounts. Then, as you refine your requirement, you can reduce permissions by defining customer managed policies specific for your use cases. That achieves the goal of least privilege permissions. Next, we'll understand what are customer managed policies and when should I use them. To grant only the permissions required to perform tasks, you can create customer managed policies that are specific to your use cases and resources. Use customer managed policies to continue refining permissions for your specific requirement. Next, what are inline policies and when should I use them? Inline policies are embedded in and inherent to specific IAM roles. Use inline policies if you want to maintain a strict one-to-one relationship between a policy and the identity to which it is applied. For example, you can grant administrative permissions to ensure they are not attached to other roles. Next, what are resource-based policies and when should I use them? Resource-based policies are permissions policies that are attached to resources. For example, you can attach resource-based policies to Amazon S3 buckets, Amazon SQS queues, VPC endpoints, and AWS key management service encryption keys, etc. So, use resource-based policies to grant direct cross-account access. With resource-based policies, you can define who has access to a resource and which actions they can perform with it. Next, what is role-based access control, which is RBAC? RBAC provides a way for you to assign permissions based on a person's job function, also known outside of AWS as a role. IAM provides RBAC by providing IAM roles with permissions that align with job functions. You can then grant individual access to assume these roles to perform specific job functions. With RBAC, you can audit access by looking at each IAM role and its attached permissions. Next, how do I grant access with RBAC? As a best practice, grant access only to the specific service actions and resources required to perform each task. This is known as granting least privilege. When employees add new resources, you must update policies to allow access to those resources. Next, what is attribute-based access control, which is ABAC? ABAC is an authorization strategy that defines permissions based on attributes. In AWS, these attributes are called tags, and you can define them on AWS resources, IAM roles, and in-role sessions. With ABAC, you can define a set of permissions based on the value of a tag. You can grant fine-grained permissions to specific resources by requiring the tags on the role or session to match the tags on the resource. For example, you can author a policy that grants developers access to resources tagged with the job title like developers. ABAC is helpful in the environments that are growing rapidly by granting permissions to resources as they are created with specific tags. Next, how do I grant access by using ABAC? To grant access by using ABAC, first define the tag keys and values you want to use for access control. Then ensure your IAM role has the appropriate tag keys and values. If multiple identities use this role, you can also define session tag keys and values. Next, ensure that your resources have the appropriate tag keys and values. You also can require users to create resources with appropriate tags and restrict access to modify them. After your tags are in place, define a policy that grants access to specific actions and resource types, but only if the role or session tags match the resource tags. Next, we'll see how to restrict the access. So, how do I restrict access by using IAM? With IAM, all access is denied by default and requires a policy that grants access. As you manage permissions at scale, you might want to implement permissions guardrails and restrict access across your accounts. To restrict access, specify a deny statement in any policy. If a deny statement applies to an access request, it always prevails over an allow statement. For example, if you allow access to all actions in AWS but deny access to IAM, any request to IAM is denied. You can include a deny statement in any type of policy, including identity-based, resource-based, and service control policies with AWS organizations. So, what are AWS organization service control policies, which are SPCs, and when should I use them? SPCs are similar to IAM policies and use almost the same syntax. However, SCPs don't grant permissions. Instead, SCPs allow or deny access to AWS services for individual AWS accounts with organization member accounts or for groups of accounts with an organizational unit. The specified actions from an SCP affect all IAM users and roles, including the root user of that member account. Next, we'll look into how to analyze access in IAM. So, how do I work toward least privilege permissions? When you get started granting permission, you can start with broader permissions as you explore and experiment. As your use cases mature, AWS recommends that you refine permissions to grant only the permissions required with the goal of achieving least privilege permissions. For that, AWS provides tools to help you refine your permissions. You can start with AWS managed policies, which are created and administered by AWS and include permissions for common use cases. As you refine your permissions, define specific permissions in customer managed policies. To help you determine the specific permissions as you require, use AWS IAM Access Analyzer. Review AWS CloudTrail logs and inspect lost access information. You can also use IAM Policy Simulator to test and troubleshoot policies. Next, what is IAM Access Analyzer? Achieving least privilege is a continuous cycle to grant the right fine-grained permissions as your requirements evolve. IAM Access Analyzer helps you streamline permissions management in each step of this cycle. Policy generation with IAM Access Analyzer generates a fine-grained policy based on the access activity captured in your logs. This means that after you build and run an application, you can generate policies that grant only the required permissions to operate the applications. Policy validation with IAM Access Analyzer uses more than 100 policy checks to guide you to author and validate secure and functional policies. You can use these checks while creating new policies or to validate existing policies. Customer policy checks are a paid feature to validate that developer authorized policies adhere to your specific security standards ahead of deployments. Customer policy checks use the power of automated reasoning, provable security assurance backed by mathematical proof to ensure security teams to proactively detect non-conformant updates to policies. Public and cross-account findings with IAM Access Analyzer help you verify and refine access allowed by your resource policies from outside your AWS organization or an account. Unused access with IAM Access Analyzer continuously analyzes your accounts to identify unused access and creates a centralized dashboard with findings. The findings highlight unused roles, unused access keys for IAM users, and unused passwords for IAM users. For active IAM roles and users, the findings provide visibility into unused services and actions. Next, how do I remove unused permissions? You might have IAM users, roles, and permissions that you no longer require in your AWS account. It is recommended that you remove them with the goal of achieving least privilege access. For IAM users, you can review password and access key last used information. Likewise, for roles, you can review role last used information. This information is available through the IAM console, APIs, and SDKs as well. Last used information helps you identify users and roles that no longer in use and safe to remove. You can also refine permissions by reviewing service and lost access information to identify unused permissions. If you enable the Unused Access Analyzer as a paid feature, IAM Access Analyzer continuously analyzes your account to identify unused access and creates a centralized dashboard with findings. The dashboard helps security teams review findings centrally and prioritize accounts based on the volume of findings. Security teams can use the dashboard to review findings centrally and prioritize which accounts to review based on the volume of findings. The findings highlight unused roles, unused access key for IAM users, and unused password for IAM users. For active IAM roles and users, the findings provide visibility into unused services and actions. That simplifies inspecting unused access to guide you toward least privilege. With this feature, you pay per IAM role or IAM user analyzed per month. Next, what is the IAM Policy Simulator and when should I use it? The IAM Policy Simulator evaluates policies you choose and determines the effective permissions for each of the actions you specify. Use the Policy Simulator to test and troubleshoot identity-based and resource-based policies, also IAM permission boundaries and SCPs. So, what are IAM Access Analyzer custom policy checks? IAM Access Analyzer custom policy checks validates that IAM policies adhere to your security standards ahead of deployments. Custom policy detect non-conformant updates to policies. For example, IAM policy changes that are more permissive than their previous version. Security teams can use these checks to streamline their reviews, automatically approving policies that come from with their security standards and inspecting more deeply when they don't. This new kind of validation provides high security assurance in the cloud. Security and development teams can automate policy reviews at scale by integrating these custom policy checks into the tools and environments where developers author their policies, such as their CI/CD pipelines. Next is, what is IAM Access Analyzer Unused Access? IAM Access Analyzer simplifies inspecting unused access to guide you toward least privilege. Security teams can use IAM Access Analyzer to gain visibility into unused access across their AWS organization and automate how they right size permissions. When the unused access analyzer is enabled, IAM Access Analyzer continuously analyzes your accounts to identify unused access and creates a centralized dashboard with findings. The dashboard helps security teams review findings centrally and prioritize accounts based on the volume of findings. The findings highlight unused roles, unused access keys for IAM users, and unused password for IAM users. For active IAM roles and users, the findings provide visibility into unused services and actions. I really appreciate your interest in this session. Meet you again in my next session. Until then, take care.